In this problem, we are told that the sample space S is all the ordered pairs of two whole numbers, the first one from 1 to 3 and the second from 1 to 4. So essentially what this means is that if we have these ordered pairs x, y, x is an element of the set 1, 2, 3, and y is an element of the set 1, 2, 3, 4. So essentially we're just pairing every term of x, every possibility of x with every possibility of y. So for our ordered pairs, we have 1, 1, 1, 2, 1, 3, 1, 4. Then we switch to x equals 2, so 2, 1, 2, 2, 2, 3, and 2, 4. And then our last possibility for x is 3, so we have 3, 1, 3, 2, 3, 3, and finally 3, 4. So there is the set of all ordered pairs of two whole numbers, the first one being from 1 to 3 and the second one being from 1 to 4. So in this next part, we're told let event A equal the sum is even and event B equal the sum is odd. So what does that mean? Well, that means that A equals, let's just go ahead and write their sums above here. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, so on and so forth, all the way down. So now which ones are even? Well, 1, 1 is 2, so that's even. 1, 3 is 4, 2, 2 is 4, 2, 4 is 6, 3, 1 is 4, which is even, 3, 3 is 6, which is also even. So it's going to be, make sure we have them all, 1, 1, 1, 3, 2, 2, 2, 4, 3, 1, and 3, 3. So there's event A. Event B would be all the others, because if it's not even, it's odd. So event B equals 1, 2, 1, 4, 2, 1, 2, 3, 3, 2, and 3, 4. And then the closed bracket to signify the end of the set. Now part 3, or part C rather, we want the probabilities of these events. So part C, the probability of A. Well, how many events are, or how many events in the total sample space are part of event A? So the number, or how many outcomes. So the probability of A equals number of outcomes in A divided by total number of outcomes. So if we look at this, there are 1, 2, 3, 4, 5, 6 events in, or 6 outcomes in event A. And then how many outcomes are there total? Well, if we look at the sample space again, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes in the entire set. So we're looking at 6 outcomes in event A over 12 possible outcomes, which equals 1/2. Now the probability of event B, it's going to be the complement of the probability of event A, because B is the complement of A, but we'll look at it in the same way that we did before. Number of outcomes in B over the total number of outcomes. So 1, 2, 3, 4, 5, 6 out of 12 possible outcomes equals 1/2. Now with part D, we're looking at the event A and B. So D is A and B. Well, A and B, one is the complement of the other. The first one is the sums are even. The second one is the sums are odd. So there's nothing in both A and B. They don't intersect. None of the events or none of the outcomes in the sample space are in both event A and event B. So A and B is just going to be the null set. Now A or B, that's combine the two sets A and B. Well, but that just equals S. That equals the entire sample space, because when we put them back together, when we put the sum is even and the sum is odd together, we get every event or every outcome that was in the original sample space. So this makes part E a little bit easier. The probability of A and B occurring is 0. There's nothing in the set, so the probability is going to be 0. And the probability of A or B, well, it's the entire sample space, so it's going to be 100%. Now in part F, we're asked about the complement of B. Well, we kind of went over this. The complement of B, so F B prime or B complement, that's just going to equal A, because everything that's outside of B is in A. So that means the probability of the complement of B equals the probability of A, which we already found. It's 1/2. Part G, we're looking for the probability of A plus the probability of A complement, or the complement of A. But as we already discussed, A complement is just B. So the probability of A plus the probability of the complement of A equals the probability of A plus the probability of B, which equals 100%. They're both 50%. They're both half, which is 50%. We could also just recognize here that anytime we have the probability of an event and the probability of its complement, since the complement is everything that's not in that event, it's always going to be 100% if we have that. Now, finally, with part H, I'll go ahead and write this over here. So with part H, we're looking for the probability of A given B. Well, so if we have an event in B, or if we have an occurrence of B, any one of these outcomes that are in B, A can't occur because they're complements of one another. So the probability of A given B is 0. And likewise, the probability of B given A equals 0, because if we have one of these combinations that's in event A, we're not going to have any combination in event B. There's no overlap. So yes, they're the same. And it's because A and B are complements.